Looking at covalent bonding this time, two quick questions, and it's asking us to look, I'll just say, at covalent bonds this time. And what it's asking us in the first question is, how do atoms come together to form a single covalent bond? And the premise of covalent bonding is through the sharing of electrons. So if we have two substances that come together, they will share electrons. Okay, so they're going to share a pair of electrons, crucially as well. There's got to be two of those things. So we need to be sharing two electrons or a pair of electrons. Okay, in most cases, it's one from each side. And in order to do that, the two elements that have to come together both have to be non-metals. Okay, remember, metals would generally bond ionically if they were going to come together with a non-metal. So two non-metals come together and bond covalently because they're going to be able to share and both fill up their shells without giving anything away. And an example, a random example, is borane. Contains covalent bonds between boron and hydrogens, and the formula is literally as simple as it looks. It is a case of adding up the elements within it, and we've got BH3. Okay, it gives us the molecular formula, so that's how many atoms are actually within the element, within the compound, sorry. So BH3. And what you could see on the previous, on the BH3 diagram, is these sticks. Okay, so these sticks between the boron and the hydrogen. And again, we've got one here between hydrogen and hydrogen, this diagram here. And what this is illustrating is a different way of representing this shared pair of electrons. And what you'll notice is that you have a singular bar, and a singular bar represents a single covalent bond, which is the sharing of a pair of electrons. So two electrons represents one singular bar. So with methane, which is this CH4 molecule, carbon is surrounded by four hydrogens. Each of these is a singular covalent bond, one pair of electrons, 2, 3, 4 pairs of electrons, giving us a carbon with four sticks around it and four hydrogens. Likewise, the water molecule below has hydrogen covalently bonded to oxygen, which is also covalently bonded to another hydrogen. And then in the final example, slightly different, you notice there are four electrons in that overlap region. That's actually then two pairs of electrons, and you represent that by a double bar to represent what's called a double covalent bond. But ultimately, each bar represents two electrons, a pair of electrons between each substance.